angular momentum of the electron. I have told you just now that the electron have the orbital angular momentum, spin angular momentum, and now we will have the total angular momentum. So because of these two types of angular momentum, there will be the resultant of these two. So the resultant of orbital angular momentum and the spin angular momentum gives rise the total angular momentum, and this is denoted by the quantum number J, as I will tell you just now. The vector sum of orbital angular momentum and spin angular momentum gives total angular momentum. Total angular momentum denoted by mg. Denoted by L total. So this L total is equal to this L orbital plus L spin. This is the sum of these two. So quantum mechanically this L total, this is equal to square root of J into J plus 1 into H upon 2 pi. And this L total, this is the J is the total quantum number. J equal to total quantum number, and this J equal to L plus S. The L the orbital quantum number, S the spin quantum number. So this is equal to L plus S, and this is we can have that this L plus half. This is equal to J. So this S is equal to half. So this is not total angular momentum, the total quantum number. Now we can have what? S orbital, P orbital, D orbital. Now this L equal to 0, 1, 2, 3 and so on. So now if we have the orbital, then this will be now, this is now P orbital, this is now S orbital, this is now P orbital, this is now D orbital, and this is now F orbital, and so on. So for S orbital, we are having this L equal to 0, for P orbital, L equal to 1, for D orbital, L equal to 2, for F orbital, now this L equal to 3. So now we put these values here, then we can find this L total. For S orbital, electron L equal to 0. So now this J is equal to 0 plus 1 by 2, or this J is equal to 1 by 2. So now what we have, that this L total, this is equal to square root of 1 by 2 into 1 by 2 plus 1 into h upon 2 pi. So now put the value of J in this formula. So now this is equal to square root of 3 into h upon 4 pi. This is equal to L total. This is L total for S orbital. S orbital. And now for P orbital, electron, L equal to 1. So this J is equal to 1 plus 1 by 2. So this J is equal to 3 by 2. So now we can have this L total. This is equal to square root of 3 by 2 into 3 by 2 plus 1 into h upon 2 pi. So this is now 5 upon 2. So 5 into 3 is now 15. So square root of 15 into h upon 4 pi. So this is now L total. So this is for p orbital electron. And now for d orbital electron. L equal to 2. So now this J is equal to how much? J is equal to 2 plus half. And J is equal to, this is now 2 and half, so this is now 5 by 2. 5 upon 2. So now this L total is, L total is equal to square root of 5 upon 2 into 5 upon 2 plus 1 into h upon 2 pi. 5 and 2, 7, 7 and this 5, 35. So square root of 35. Square root of 35 into h upon 4 pi. This is now L total. And now for F orbital, electron, this L is equal to 3. So now this J is equal to 3 plus half. So this J is equal to 7 upon 2. So now if you have this L total equal to square root of, this is now your 7 by 2 and this is now 7 by 2 plus 1 into h upon 2 pi. So now put the value of J, then this will come out to be how much? This is now 7, 7 and 2 9, 9 and 7 63. So square root 63 into h upon 4 pi. This is equal to L total. This is not so much. So thus you can see that the total angular momentum is never zero, while the orbital angular momentum may be zero. So the spin angular momentum and the total angular momentum are never zero. So now if you have the ratios cannot be to be find out, because these are square roots value 3 now 3, this will not be to be here, so this we leave it. 5 into 7, 7 into 5, 35. So 35 into h upon 4 pi. Thus L total is not equal to 0. This always exists. So whenever the electron moves in the orbit around the nucleus, it always have the orbital, it always have the angular momentum. So thank you very much.